All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are continuing our Kaggle learning. I don't know what to call this, adventure, journey, whatever. We are continuing with Kaggle Learn, and we are currently in the Intro to Machine Learning course, and we are currently doing, what's the name of the exercise? I forgot. Your first machine learning model. That's the exercise we are currently doing. So we are going to be training our first machine learning model. Now, give me a second while I open up my stream. While I open up my stream manager, actually. Where is it? The thing doesn't seem to be appearing. What was the way to get to? Oh, like that. Okay. Let's go to the creator dashboard, stream manager, and I think we are good to go. All right. Okay. So, let's carry on. Now, uh, just some quick information. What I'm doing here is that the way that I've set this up is that I'm gonna I'm gonna be doing stuff in the notebook itself, but for the sake of having IntelliSense, for the sake of being able to use IntelliSense, which it definitely helps if you have IntelliSense and you don't have to remember various things like, function names and function parameter orders and stuff like that. It helps. So for the sake of having IntelliSense, I am doing the coding in NeoVim. So the exact same code that I'm going to be doing here in this notebook, in this exercise, I'm going to recreate that in NeoVim just so that I'm able to do it in a slightly less frustrating way. And I'll test out the code in NeoVim and then I'll drop it into this exercise notebook, into the code cell here. So what I'm going to do is, okay, let's say not this specific cell, but let me run this. So the setup, okay, it's done. Great. So now we have this exercise, right? Specify prediction target. Select the target variable which corresponds to the sales price, Save this new variable called y. You'll need to print a list of the columns to find the name of the column you need. So something simple like this, I probably wouldn't need IntelliSense for it because I remember, data frame dot columns. What is the name of the data frame though? It is home underscore data. So let's try that. Home underscore data dot columns. Let's run this. I also downloaded this on my remote machine, and from the remote machine I need to copy it over. So give me a second to do that as well. What was it? Yeah, NeoVim, I think train. Yeah. Now this is a big file. Okay, I think we're good. So let's yank all the way to the end. Oh, it's not that big actually. It's 1,400 rows and a bunch of columns compared to the other data set, which was much, much more. Now I'm gonna sort of replicate the what do you call it? I'm going to replicate the directory structure here just so I have the exact path. So let's say make directory data sets, I believe it was. Yeah. No, it's data. Okay. Data home data for ML course. Okay, and then we'll cd into that. Actually, we don't need to cd into that. We need to create a thing here. I believe this is yeah, this is called train.csv. So we're going to open this up. And we're going to paste this. I hope it pastes properly. I hope it pastes the right thing. Is this working? Okay, it doesn't seem to be pasting. Give me a second. Let me go back here and yank the thing again. Okay, copied. Now come back here. Okay, this time it worked. I don't know what happened the last time, but anyways. Okay, cool. So we have the data set here. And now for practicing this, or for basically doing the notebook stuff practically here, I guess I could get rid of... I wonder if I should make a new Python file. Just so... Yeah, let's do py02.py. Yeah. And then we can probably close this, but actually no, we can leave this open. Yeah, we can leave this open. So we need pandas. So pandas as PD. Then we need... Actually, that's all they've imported. They haven't imported anything else. I don't need to import the learn tools stuff. They haven't imported Scikit-learn yet. I'm guessing that's going to come later on, because so far they're only doing pandas stuff. Yeah, okay. So this is an exercise for, I believe they want us to do a decision tree. Yeah, yeah. So this is all from like the previous thing. So we're going to do scikit-learn dot tree, I believe. Yeah. From, actually it's supposed to be from sklearn dot tree import decision tree regressor. What was the next one? Oh, I think that's it. Oh, that was also the pretty print thing. Yeah, I can leave that for later. Okay. What else? Yeah. So now we can do data. Let's give it similar names to what we have here. Data file path equals. In my case, it's going to be data slash, actually. So this is something convenient here. I can specify a path and it'll kind of go along with that. So I'm guessing if I did slash, then it goes to root. And if I do slash home, then within home, what other stuff we have, it goes to that. And if I want the current directory that this is running in, I can use dot. And then when I do slash, then it does this. So yeah, this is our path, and then home data equals pd.read csv data file path. Okay, let's call it Iowa file path just for the sake of, you know, not making it confusing. Okay, yeah, I think that's good. And now we move on to the next thing, which is displaying the columns. So we display the columns, and what exactly was it? Select the target variable. The target is what we are trying to predict, which corresponds to the sales prices. Is it sale price? So our target is Y. That's what we are trying to predict, right? So that would be home data dot sale price. And I could print out y dot describe. It doesn't know that it's a data set, or it doesn't know that it's a data frame. Yeah, I guess not. If I access it in a different way, is it a data frame or a series? I don't think in this case it would be a, yeah, I don't think in this case it would be a data frame, would it? Wait, let's print out the type for Y and see what it gives us. Yeah, this is a series. This is not, so I don't think I can use describe on this. But yeah, okay. We have our thing. See, I'm kind of glad that I've been side by side. I've been doing more research on these terms. Like yesterday, I was trying to have a conversation with Gemini about the terminology surrounding machine learning, specifically terminology like fitting and I don't know, fitting the data to the model, or um, what else was there? There was fit the model to the data or fit the data to the model. And then there was also overfitting and underfitting, and Gemini tried to explain these things to me. Also stuff like features, independent and dependent variables, continuous and discrete variables, stuff like that. And just like what I was thinking, it'll become more clear once I start doing more, once I start creating and training and using more ML models. These terms will become a little more clear to me. But yeah, okay. So this is our target, meaning this is what we are trying to predict. Okay, so here we are going to do home underscore data dot sale price. I hope I've got the thing right. Okay, great. Wait, I'm not done. Hold on. Why is this not letting me? Why is this not letting me restart the thing? Give me a second. No, I wanna reset this entire exercise. And I thought I had reset it because I'd gone and deleted the version that I had, but apparently I was mistaken. So what I'm gonna do is I'm gonna close this. Actually, from here itself, I can go in there. So what is it? Kaggle slash me slash code, I believe. Yeah, Kaggle slash me slash code. And in here, by the way, yesterday, I also looked into downloading datasets using the Kaggle CLI, and holy shit, dude, it is straightforward. It is it's a pretty straightforward process. Like you have, and also it's a sophisticated process as well. Sophisticated not in a bad way, in the way that you have a lot of options, if that makes sense. So you're able to customize what you are doing. You're able to search for various things. Give me a second. Let me finish this thing. Okay, let's delete that. Great. Awesome. So now I'm gonna come here and refresh this page, and hopefully it'll let me open up a fresh version of the notebook. Okay, the thing is opening up now, so I think I can switch back from BRB and we can just wait. In the meantime, I can continue reading this thing. By the way, there's this thing about containers and containerized technologies that I've been kind of interested in, because I found out about, so I read about container type technologies a while back, but I didn't really bother looking too deep into it. Stuff like Docker, for example. I later also found out about something called Linux containers. These are essentially containers in which you can run applications. I don't know if you can run multiple applications, but you can run at the very least one application. And the advantage here is that you're not running it on top of you're not running it on top of an OS. I believe you're running it essentially on top of the kernel. You will still require some kind of management utility in order to manage these multiple containers, but you can actually do that. There are tools available to manage these multiple containers, so you can have this kind of a system set up where you can have multiple containers running. I think they can have multiple apps. I'm not sure. I don't want to give wrong information. I'm still fairly new to this technology. I forgot what was the name of that. Uh, I mean, there's a couple of them, but there was one specific one that I had looked into, which was what was the name? It just a second. Yeah, I can't remember. What was the Okay, let me look up LXC. Okay, I would need to open up Firefox and then restore. Okay, right. Okay, LXC container. Oh, Proxmox. That's what it was called. Proxmox. Proxmox uses LXC to run lightweight Linux operating systems, offering better resource efficiency than traditional virtual machines by sharing the host's kernel. Users can create LXC containers via the web GUI, deploy specific applications using built-in templates, or even run Docker containers within an LXC. Key advantages include faster deployment, complete control over a Linux environment, and snapshot capabilities, making LXC ideal for individual services and resource-constrained environments. So yeah, this is something that I've been meaning to kind of explore, and I also want to explore Docker, but I want to explore Docker on Linux. I don't know if it's possible to do it like just bare bones on the kernel, but I want to explore it on Linux because apparently the containerized aspect of it offers you a decent advantage in terms of um, well, in terms of keeping things sandboxed, keeping things containerized. So like whatever you are running, if you need to install a bunch of like dependencies, a bunch of packages and stuff, and if you need to make changes here and there, you can do a bunch of those things within the container, and it doesn't affect the host system. I still don't know how. I still don't know the specifics around it. Like, what are you supposed to do in order to prevent it from affecting the system, or if it's just built in such a way that you can do whatever you want in it, and it's kind of like running a virtual machine but not really running a virtual machine. It's much lighter than a virtual machine. But yeah, I need to explore Docker at some point as well. Okay, I had a bit of a hiccup. Yeah, I think there was a bit of a hiccup here. I think we're good. Yeah, okay. Enough about the Linux container and the Docker thing, but I do want to check out both of these technologies because I have seen Docker being mentioned in a couple of other situations as well. Not just in like, this experimentation stuff that I'm doing, but also in like more like production environment kind of things. There's a bunch of like tools that I've been trying to, well, I mean, I have used them, but a bunch of the tools that I have set up, they did also give an option for Docker. I believe SRS also suggested Docker, like straight up. That was like the first thing they suggested. They didn't suggest the method that I later on discovered, which I'm glad that they actually mentioned that there's the other method. Otherwise, I would have been forced to explore Docker. But yeah, they didn't mention that right off the bat. I had to like go into a separate page to find that information. What they did mention was that, yeah, you can do so and so thing very easily using Docker. And I've seen Docker being mentioned in a bunch of different places, so I'm kind of interested in learning about it. I feel like it's going to be helpful, and I want to explore the Linux container thing because I do want to test this out on a different machine. When I get a chance, I do want to um, do something like set up Proxmox on another machine and then set up a bunch of Linux containers in there so I can run like services for various things. But yeah, okay. Uh, what was I doing? Why were we? Oh yeah, I was waiting for the the notebook to load. Okay, so I think hopefully this should be a fresh version of the notebook. So once this runs, sorry, zoned out in between. Let me while this is running, let me just read that the container thing. Oh, you know what? Never mind. Never mind. The thing is running and we are good to go. Right. So home underscore data dot columns. We run that and that gives us this. And then we do home underscore data dot sale price. Hopefully that's correct. That is correct. Amazing. Wait, why is it jumping straight to... Oh, okay. You know what? No, that's fine. At least I'm able to complete the rest of the notebook, so I'm not gonna complain. Because I mean, I have finished this notebook. I have finished this entire exercise in the past, but I want to redo it because I'm kind of refreshing my knowledge of... I'm kind of restarting learning data science. So I kind of want to do it from scratch as much as I can. And that's why I'm going to take my time to do this. Fortunately, this is the only such exercise in this course. Probably in the other courses, I might have a similar situation arising. But at least in this course, this is the only exercise where I'm going to have this issue. All the other exercises, I never really went further with them. Like I never completed... Hold on, let me show you the list. I never completed the other exercises. Even here you can see model validation. I didn't finish the exercise. Apparently I went up to 75%, but I didn't like finish the exercise. So I have to finish that, and then I have to read all of the others and also finish their exercises. So that should be fun. That should be interesting. So we're gonna get to learn quite a bit here. Dude, you know what? I'm wondering if I should do this thing where so at a certain point I'm gonna have to end the talking stream because reasons, but I'm wondering if I should just fire up a mute stream after that so I can continue. Because like I don't see a reason why I can't do that, because I'm gonna be doing this anyways, right, for the next couple of hours. Even after I end the stream, I'm I'm still doing this. So yeah, I don't see why not. Uh Nah, actually there's other stuff that I might want to do that would require um my other machines. So if I'm not doing that on stream, I feel like that would work out much better. Anyways, I'll see if I wanna do that. But yeah, we are currently in this. We are in your first... I was about to say your machine, your first machine. What machine? What is machine? Anyways, your first machine learning model. So we are currently in the exercise portion of this. We are done with the tutorial portion of this. We are done with the whole reading and stuff. So I just want to finish this this exercise. Okay. Um, let's look at the hint and solution as well, just to see if there's any extra information we can learn from that. We've got the thing right anyways, but just so we can get some information for the future. Hint: use so and so dot column. The column you want is at the end of the list. Use the dot notation. Yeah, okay, all right. Yep, that's true. Then we have the solution. Okay, then create X. Okay, this is interesting, right? Because they mentioned X and Y, right? I need to explore this thing because they mentioned it as a two-dimensional kind of thing, X and Y. But the thing is, Y can have multiple features in it, right? And X, at least for now, X is... No, Y can have one feature in it, and X can have multiple features in it. But like when you say X and Y, it kind of makes you visualize it as a two-dimensional grid. But in reality, Y, which is by convention what we assign to whatever variable we are predicting, Y is basically how we denote that, oh yeah, this is what's being predicted. Um, why was I talking about the convention? I forgot. Anyways, I need to explore this thing further because they presented it as a graph, as a two-dimensional graph. When you say X and Y, then like it's gonna make people think of like, you know, a two-dimensional grid, a two-dimensional graph with X and Y axes, right? In this kind of a setup, usually when you have like a two-dimensional grid, it's two variables. It's not one. It's no, actually no. It's not words. It's two variables. It's not more than two. That's what I was trying to say. It's usually not more than two, but in this case, there are more than two because X doesn't represent one variable, it represents multiple variables. And I believe we are about to do that here. Give me a second. Okay, right. Now you will create a data frame called X holding the predictive features. Oh, you know what? Let me also do the thing side by side here. Wait, hold on. What's here? Oh, yeah. So we have Y, and did I print out anything? Was I supposed to print something out? No, that's done. Okay, great. Okay, since you want only some columns from the original data, you'll first create a list with their names, with the names of the columns you want in X. Okay, so let's create a thing here called X. Oh, feature names. I was trying to think of a variable name, but yeah, these are called features, right? So feature names. Feature names equals lot area, year built, then first floor SF. I don't know if all these columns are called exactly that. Hold on. Let's just make sure. First floor SF. Yeah, okay. All right. These are the exact names. Where's the lot thing? Lot area. Okay. All right. These names are correct. Okay. What's next? Second floor SF. Then full bath. Then bedroom above GR. So does that mean its bedroom is not on the ground floor? Okay. Total rooms above GRD. Okay. Anyways. Yeah, we can do this. And oh yeah, I remember Python had this thing, right? If I leave a trailing comma, then it kind of collapses the thing. Or if collapsing it would make it if collapsing would make it really long past a certain point, then it does this thing, which I'm not complaining about that. But I just want to make sure I'm remembering right. We remove this. Yeah, it does this. So if collapsing it is gonna or if squashing it is gonna make the line longer past a certain character count, then it expands it down into this kind of a list. But another way to force it to expand into that list is this. So if quite often when I'm creating these kinds of lists, then I prefer to have it in this kind of a format where I've done it like, line by line. I don't want all of it side by side always. And if I hit save and it squashes the thing, then my formatting just goes to hell, right? So having the trailing comma, I learned that this is a good way to stop the formatter from actually squashing the thing. Right, bedroom above ground and then total RMS above GRD. Okay, I think that's good. That's our feature names. Then we want to do X, home data. What was it? I think it was this. Yeah. So keep in mind, at this point, we are just trying to remember this stuff. Later on, it's going to be going into more advanced pandas stuff. And while I do know slightly, like I'm not a beginner in pandas, it's going to be fun relearning about pandas again, because I'm pretty sure it's going to fill in gaps of knowledge that I didn't have before, that I didn't even, take the time to learn. Because I learned the basics of pandas, and then I went on to learn what was specifically needed for stuff that I was doing at the time with pandas, and also stuff that was needed for, data science and machine learning and stuff. But that doesn't always include all the features that you could possibly be learning that are related to data science. So I still have quite a bit to learn. And so going through that pandas course is going to be pretty useful. I saw somebody requesting that they do a course for NumPy as well. I don't know if they ever set something like that up. Because they have what is this? I think this is a pandas course. Yeah. In here, I don't know if let's take a look at intermediate machine learning. I wonder if they introduce NumPy there, because NumPy is super useful for this purpose, like for data science related stuff. It is incredibly useful, not just pandas. There's a bunch of like NumPy related features that you will be using later on. To be fair, I've ended up using them a lot in stuff like deep learning. So with PyTorch stuff, with like tensors. However, there have been other situations as well where I had to use like NumPy specific stuff. So I'm wondering if they do go into detail with NumPy, because I haven't seen them mention NumPy so far. I don't know if it's just because the need hasn't arisen yet. What else was there? Data visualization, feature engineering. A lot of this focuses on Scikit-learn and Pandas. I'm gonna have to look into at what point they go into NumPy. Yeah, I'm gonna have to look into at what point they go into NumPy, because I don't remember if they ever like went into it. At least in the basics, they haven't touched it so far. But yeah, okay. Um, what were we doing? Okay, yeah, feature names. Okay, here what we could do is we could print out x dot describe. Okay, and then we can, oh God, don't do that. What just happened? Was I trying to do that? No. O2. Yeah, there it is. So this is our data. We have all of these are all the features essentially. These are the columns that we had in the list. Okay, cool. So this is the data that we are looking for, right? So the features are, oh God, I have to type that again. No, hold on. Okay, we can type it again. Wait, can't I just like do this? Yeah, okay. I don't know if this was better or worse. Oh, you know what? You know what? Yeah, this is not that bad. Actually, this is, nope, this is better. Definitely. Okay, okay, okay. Done. Awesome. So these are our feature names. And then in here, we want home underscore data feature names. So if I run this, we should be good. Correct. Awesome. Let's take a look at the hints and solution. See what it's saying. Capitalization and spelling are important when specifying variable names. Use the bracket notation when specifying data for X. Yeah, it's kind of interesting. So back when I was learning about pandas, I remember learning about the dot notation for being able to access specific columns, but I never actually used the dot notation. Like anytime I needed to access a column, I would use the bracket notation. And the crazy thing is, I didn't even call it the bracket notation. I didn't call it bracket notation and dot notation, dot notation. Um, I just I just didn't call it anything. I called it accessing so and so column. But this is great because this is kind of introducing us to both bracket notation and dot notation. So hopefully in the future I'm gonna remember to use this. Dude, this is great because this course, not just this course, but like the future courses as well, they introduce you to all of these things, right? They they teach you the basics and then they give you like a hands-on experience as well through like exercises and stuff. And then you have the option to, you know, go and explore data sets and go and participate in competitions and try to solve various problems and just experiment on your own. So you can like improve your knowledge and experience. So you can build up on the knowledge and experience that you gained from these courses. But like they help you take your first steps into data science and machine learning. It's crazy, dude. Okay, right. So moving on. Review data. Before building a model, take a quick look at X to verify it looks sensible. Print description or statistics from X. Okay, so that would be x.describe. This is also something that I don't use very often, the describe thing. I should use it more often. And this is one of the reasons why I want to get into like just randomly exploring data sets. At some point, I want to start doing this thing once I get better at data analysis, and once I learn about more of these techniques, then I'm gonna know exactly how to handle the data and how to find patterns in data. Not necessarily trying to predict anything, but just trying to find patterns in the data, trying to understand the data from various different points or various points of view. Okay, print the top few lines. So that's x dot head. Okay, that's done. Awesome. Then specify and fit the model. Create a decision tree regressor and save it as Iowa model. Okay, all right. So I'm going to need to do this on the other machine first, just so I have IntelliSense and okay, for model reproducibility, set a numerical value for random state when specifying the model. Yeah, I'll set it to just 1. Okay, so Iowa underscore model equals decision tree regressor. And this takes in, I forgot the order in which, was it X first and then Y? I think so. Oh, actually, no. Here it's just a random state that I have to specify. I forgot about that. So then we have to fit the model. So model.fit, and this is where we specify X and Y. And it's still kind of interesting because like they mention X and Y, and like anytime I see X and Y, my mind goes towards like a two-dimensional grid, right? But in this case, we kind of have to expand our thinking because X doesn't represent one value. X represents multiple values. But we are still thinking of it in terms of like two-dimensional. There's something to explore there. I need to talk to Gemini about this way of thinking because I feel like there's something. I feel like if I explore this more, then I'm gonna get to learn a lot about. Um, I don't know. I don't even know what I'm gonna get to learn from it. But I have a feeling that I'm gonna get to learn something from it, which is why I wanna try it. And okay, I think that should be it, right? So if I comment this out and then save and then go here and run this. Okay, yeah, that's done. So here we can do decision tree regressor, X and Y. See, this is where IntelliSense is useful because like this doesn't really give that. Oh, actually, in some cases it would give. In the past, dude, getting IntelliSense to run was it would be kind of a gamble, like whether it would actually work or not. Sometimes I would have to do certain things to trigger it. Sometimes I would have to just wait until it kicks in and starts suggesting things properly. Sometimes there would be libraries in which it just wouldn't work, but then it would work in other libraries. It was, I don't know. Okay, from sklearn.tree, import decision tree regressor. I hope I'm remembering this right. And then decision tree regressor x, y, and then Iowa underscore model dot fit xy. It's not xy, no. It's random underscore state equals 1. And then here we have xy. Great. Awesome. That is correct. Now let's take a look at the hint and solution. Hint, include random state when specifying model. Data is specified when fitting it. Okay, cool. Awesome. Okay, on to predictions. Make predictions with the model's predict command using X as the data. Using X as the data. Using X as the data. Save the results to a variable called predictions. X, hold on. So we are giving all of these, so these are the variables that will be used to calculate or to in this case predict y, right? So let's do something here. Hold on. So we predict, we say Iowa model dot predict. Actually, let's store this into a prediction variable. Dot predict. Let's say no. Okay, let's do Iowa model dot head. So let's give the first. Actually, no, not the. Oh, x dot head. So that we are giving only the first 10, I think. Returns the first n rows. Okay, maybe it's first 5. The function returns so and so. Okay, okay. Default is 5. Okay, all right. And then we print the prediction. Actually, let's also print out yeah, you know what? What if I did hold on, let's see, because it's the same data set that I'm using. I'm using the exact same data set that this thing has, right? So yeah, let's do so it said to use X as the data. So okay, dot predict. Let's just pass X in completely and then check. That is an error. Oh, because it's Iowa, not Iowa model. So let's change that, and yep, that's it. Great. Though I could also do x dot head, so it only gives like the first 10. And yeah, that says incorrect because I was supposed to pass in the entire data frame. But let me just confirm that these are the values. Yeah, these are the values. Awesome. Great. So, yeah, cool. Okay, use Iowa model.predict with an argument holding the data to predict with. Oh yeah, that's the hint. All right, all right. Okay, so something that like I'm trying to like slowly connect the dots in my head to understand what's going on here. So this is our model. The model takes so and so number of features. We have, I think, 7 features, and then it predicts one value, one variable. I guess the prediction thing is also called a feature. I'm not sure. I'll have to look into what the terminology is there. But like in this case, it takes in 7 of these variables and predicts one value for us. And we can pass in an array containing multiple sets of these 7 variables. And then it'll give us multiple sets of individual values. That's something to keep in mind because I remember this being a thing with linear regression as well. They haven't even touched linear regression so far. They've done decision tree regression, which I should okay, now that we are learning about decision tree regression and we've gotten like a higher level idea of how the thing is working, I feel like after I finish this course or after I finish this exercise, maybe I should explore decision tree regression a little bit and and try and understand exactly what it's doing. Now, previously when I tried to do this exact same thing, the mistake that I made was I got distracted. I went too deep into it, trying to understand like every little detail. And because of that, I would end up getting distracted. So this time, I think what I should do is, um, this time I should just try to stick to the higher level stuff and not try and understand how the thing is being implemented. I just need to understand the conceptual overview of what's going on. Because so far, this is what I'm able to imagine. I'm able to imagine that tree, right? So what I'm getting is that it constructs this essentially a bunch of like nested if else statements. And based on that, it kind of picks the answer, which is pretty useful because I feel like that specific way of doing things can be useful for a bunch of other situations as well, not just prediction but also decision making. Like imagine you're writing like a game AI or something, and you want the AI to be able to make decisions based on certain variables. So you can feed in a bunch of these variables, and though okay, you would need to have training data. That's something to keep in mind. You would need to train the model so it can actually, I should also look into what it means to train these kinds of models, because what does it mean to train this kind of a tree? Like what exactly is happening there? I need to understand that. You see what I mean? Like I need to properly understand exactly how these elements are working, how these things are working. Because so far what I've understood is that okay, this is a model. The model is basically a decision tree, and we can fit our training data to the model and then train the model. Well, fitting it is training. So we can fit the training data to the model and then use that trained model to make a prediction on newer data. But like internally, what is happening when you're fitting it? Because like training, in my mind, it's not really able to connect with that image of a tree, like the decision tree kind of thing. My mind is not able to make that connection between training and this. Like, how am I supposed to be imagining the decision making process? I think I need to dive deeper into this to get an understanding of that. Okay, think about your code results. Use the head method to compare the top few predictions to the actual home values in Y for those same homes. What? To the actual home values in Y for those same homes. Use the head method to compare the top few predictions. Oh, the top few predictions. Okay, so we have this predictions variable here. Okay, predictions, we can print that out. Predictions dot head, and then to the actual home values in Y. Oh, wait, hold on. I didn't realize that. I could have just instead of doing what I did here, where I did predict X dot head. No, what? Oh, I guess I didn't do anything here. I think I'd done it up here maybe. Somewhere over here I tried to like print out extra values. I think it was here that I tried to print out maybe here I'd done X dot head and then it gave that error. Yeah, I think that was it. Yeah, so instead of that I could have never mind, whatever. Let me set up a print thing here and print out Y, and then we can pass in pred. Or I could do this, and then I can do pred.head. Prediction doesn't prediction doesn't have a head thing. Okay. Wait, are you sure? Okay, I guess it doesn't have it because it's a series, not... Yeah, okay. But either way, it does give us... Wait, is this a series? Wait, let me, because it's giving us one value, right? So I think it's a series. It's an ND array. If it's an ND array, okay. You know what? We'll get into this later. For now, we'll just pass in head and print out pred. I think I could do pred dot... What was it? Sale price. Now this is giving an error because it's going to be an... Okay, yeah, that's not a... It's still not a data set. It's still not a data frame. So that's why it's giving that error. But either way, these are our values, the first 5, and they match. So we can do the same thing here. Though it says predictions head. Use the head method to compare the top few predictions to the actual home values. Yeah, I'm wondering how this would work here. Would it even work here? I'm not sure. No, it doesn't work. It throws an error. Exactly the same error. numpy.ndarray object has no attribute head. So what do they mean by this? Use the head method to compare the top few predictions. Are they saying we need to do x.head? Okay, let's try this. x.head.sale price. That doesn't work. Oh, it doesn't work because the... Yeah, okay. Okay. How do I go about doing this? I'm trying to stick with what they said because they mentioned head here, so I'm like focusing on that. I guess it's home data then, right? Home data dot head dot sale price, and then we have our predictions. What's the variable called? Yeah, okay, there's an S there. Yep, there it is. The values match. So, what are they saying? Anything surprising? No. It's natural to ask how accurate the model's predictions will be and how... Give me a second. Let me just make sure we are still live, and because it seems like we've lost a lot of frames. But no, we are still good. Okay. Right. It's natural to ask, man, my system is struggling. Holy shit. Okay, where was I? Yeah, it's natural to ask how accurate the model's predictions will be and how you can improve that. That'll be your next step, which is model validation. Okay, we are officially done with that. We are officially done with this exercise, which is awesome. So now we are moving on to validation, and pretty soon we're going to be all caught up with where I had left off a while back, a couple months back, actually. Give it a second. Let this. Yeah, I think it's my system that's slowly starting to crash, but I think we can make it. I think we can make it. Okay, we need to do reading. So here's what I'm going to do. I'm going to open this up in a separate thing. Just a second. Let me open this up elsewhere. Model validation. Okay, great. Let's actually let me hydrate real quick and then we can start reading. So this text might be a little small for you guys to read, but I'm reading the thing out on a different machine, just so that I can actually read it. I've zoomed in on the other machine. I don't want to zoom in on this machine because then later on when we have to do the exercise and stuff, then I'm gonna end up having to zoom out just so that I have more space to type and stuff. So like it's a weird mess. So instead of that, I load up the same notebook on two separate machines, and on the other machine, I can zoom in, and on this machine, I don't zoom in. And then as I'm scrolling in one, I scroll in the other as well because I have both the keyboards next to me. It seems like a weird, convoluted way to do it, but like it works for me. And it looks seamless on stream as well. So at least I think it looks seamless. Well, not really seamless, but like mostly it looks okay. It doesn't look that bad. Right. Um, okay. So you've built a model, but how good is it? In this lesson, you will learn how to use model validation to measure the quality of your model. Measuring the quality is the key. Measuring model quality is the key to iteratively improving your models. What is model validation? You'll want to evaluate almost every model you ever built. In most, though not all applications, the relevant measure of a model's quality is predictive accuracy. In other words, will the model's predictions be close to what actually happens? Okay. Many people make a huge mistake when measuring predictive accuracy. They make predictions with their training data and compare those predictions to the target values in the training data. You'll see the problem with this approach and how to solve it in a moment. Oh, I remember what exactly the issue ends up being here. It's that you're testing with your training data, and because the model has been trained on that data, so it's going to perform well on that data. You want the model to perform well on different data, not that exact same data, because it's already been trained on that data. The idea is to get the model to generalize well on other data, data that it's not been trained on. So generalize well on testing data, not generalize on training data. It should train with the training data. Where was I? Yeah, you'll see the problem with this approach and how to solve it in a moment. But let's think about how we do this first. You'd first need to summarize the model quality into an understandable way. If you compare predicted and actual home values for 10,000 houses, you'll likely find, wait, if you compare predicted values of actual home values and if you compare predicted and actual home values, okay, for a reason, for some reason, I just confused myself there. Okay, if you compare predicted and actual home values for 10,000 houses, you'll likely find a mix of good and bad predictions. Sorry, zoned out. Where was I? Um, you'll likely find a mix of good and bad predictions. Looking through a list of 10,000 predicted and actual values would be pointless. We need to summarize this into a single metric. Okay. There are many metrics for summarizing model quality, but we'll start with the one called mean absolute error. Let's break down this metric starting with the last word, error. Okay. So the prediction error for each house is error equals actual minus predicted. Okay. Oh, so are we taking the absolute average of the error? Is that the idea? So if a house costs 150,000 and you predicted it would cost 100,000, the error is 50,000. With the May metric, we take the absolute value of each error. This converts each error into a positive number. We then take the average of those absolute errors. This is our measure of model quality. In plain English, it can be said, on average, our predictions are off by about X. Okay. To calculate May, we first need a model that is built in a hidden cell below, which you can review by clicking the code button. Okay. All right. Okay, so what are we looking at here? So we first import pandas, and then we have the file path, and then we have the data set being loaded. Then we have the filtered. Oh, actually, filtered, but after dropping non-numerical values, I think, or missing values. Then choose the target and features. And then we have Melbourne features, and then X, which is well, our features. And then decision tree regression, model fit. Okay, so this is basically our previous thing that we did here, where we predicted the price and stuff like that. That's basically that. I even did the drop NA thing. So yeah, that's done. Though now we need a test data set. Okay, once we have a model, here's how we calculate. Dude, I'm glad that I opened up a new Python file because I had no idea that they were going to reference a previous exercises code. So I think in the future I should probably create a new Python file for each exercise that we are doing, just so we can reference older code if there's ever a need for it. Of course, another thing I could do is put everything into one file, but like just put everything into functions. But I'd imagine as I progress through the course, and I'm doing more and more exercises, the code is going to become unnecessarily long, and I don't want that. So I guess, yeah, let's not do that. Okay, so once we have a model, here's how we calculate the mean absolute error. So we import from sklearn.metrics, import mean absolute error. Okay, and then um yeah, predicted home prices. So then we compare y to the predicted home prices. So the interesting thing is here, if we look at the types, um, yeah, so if we print out the types for y, and actually, can't I do this? Wouldn't this work? I remember this being a thing, like where I can just give spaces and it kind of like does the formatting on its own. Let's try that. Oh, type y and type pred. Is that what I call it? Pred? No, I called it res. Okay, cool. So yeah, dude, I need to keep this in mind. I need to remember this method because I rarely ever do this exact same thing. Like I've done formatted strings where you do f and then you put a placeholder within the string, and then that placeholder can then be filled in later on. You can mention that. How do I say this? I've done this kind of thing where you create like placeholders, and then you can mention that, oh yeah, this is supposed to be type y and this is supposed to be type res, and then this accomplishes that. Oh, I'm confusing this with Rust. My bad. No, 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 hold on. You don't specify this later. You specify it inside here. I'm confusing this with Rust, dude. My bad. Is it this, or am I getting this wrong as well? I hope I'm not getting this wrong. Yeah. So I've done this, right? But I rarely ever do this method, which honestly I feel like this would just be faster, especially if I'm doing debugging. This would be a lot faster. So I should probably stick with doing this. That being said, what are the values that we are getting? Series and ND array. Right, so it'll be interesting seeing. Okay, so let's calculate. Yeah, let's print out mean absolute error. What are, so there's y true and y pred. Oh, so the actual value, the expected value. So that's why we're using y, and then y pred is what was actually predicted. Now for unknown, what, I need to be able to read this. Hold on. Array like, Oh, array like of shape and samples, so and so. So it can be of any type. It doesn't necessarily have to be like, either a series or an ND array or specifically a list. Okay, this returns loss, which is a float or array of floats. If multi-output is raw values, then mean absolute error is returned for each output separately. Okay, I'll look into that later. Uh, okay, all right. Oh yeah, I have to pass in. Yeah, so res. Are we good? I think we're good. Okay, so do seem to have we do seem to have an error here. What what was the size of X? Yeah, I don't think I like sliced it. I think it's like the entire thing. I passed the entire thing in. Okay, so in my case, it is giving a much bigger error value, which is interesting. Okay, what if I do this? It is the same. Yeah, why am I getting like a different score compared to Oh, I think it's because of the number of features, because the number of features are there's extra features in here. Okay, so let's add more features. So we have rooms, bathroom. Okay, let's first of all fix this. There. Rooms, bathroom, land size, latitude, longitude. No, wait. Land size, latitude, and longitude is at the end. Building area after land size. So building area, then year built. What just happened? Oh, yeah, that's my fault. Okay, there is an error. Wait, what's the issue? Building area is not an index. It's because I spelled building wrong. My God, dude. Okay, now we have exactly that answer. 434.715.945 something something. Yep, we have the exact answer. Great, awesome, cool. Okay, now, uh, moving on to the next section. So the problem with in-sample scores. The measure we just compared can be called an in-sample score. The measure we just compared can be called an in-sample score. We used a single sample of houses for both building the model and evaluating it. Here's why this is bad. Imagine that in the large real estate market, door color is unrelated to home price. However, in the sample of data you used to build the model, all homes with green doors were very expensive. Okay, the model's job is to find patterns that predict home prices. So it will see this pattern and it will always predict high prices for homes with green doors. Since this pattern was derived from the training data, the model will appear accurate in the training data. But if the pattern doesn't hold when um, when the model sees new data, the model would be very inaccurate when used in practice. Since models or models is since models practical value comes from predictions on new data, we measure performance on data that wasn't used to build the model. The most straightforward way to do this is to exclude some data from the model building process and then use those to test the model's accuracy on data it hasn't seen before. This is called validation data. So we have the training data and validation data slash test data. There's something interesting here as well, because there's another concept within this where you essentially take the entire training data and split it up. That's exactly what this is talking about as well. But like there's Scikit-learn has certain functions that automatically do this splitting for you based on certain factors. I think at some point we'll be covering that later on. Like splitting your entire training data into training data and or splitting your data set into training data and validation data. There's it tends to be a little more complex. I mean, you can keep it as simple as just, um, this index to that index is training data and this index to that index is validation data, but there's you can actually do a lot more sophisticated stuff than just that. I'm pretty sure they'll be covering that later on. Okay, they are covering part of it here. So the scikit-learn library, the scikit-learn library has a function train test split to break up the data into two pieces. We'll use some of that data as training data to fit the model, and we'll use the other data as validation data to calculate the mean absolute error. Okay. Right. So this is our data. Melbourne model. Okay, okay. Okay, so we can just build upon the Melbourne example. I don't think we need to make something new. Right. From sklearn.model selection. Dude, I feel like I'm getting to practice this a lot more and a lot better with this workflow that I've set up, as opposed to what I was doing previously, where I would just be reading all of this stuff, just reading the code, and then I would move on to the exercise, and it would be kind of confusing that, hey, what should I select? And I would have to try and remember the thing. But now, because I'm doing it practically, so I kind of remember it. So when we do eventually move on to the exercise bit, then I'll be able to fill in the data by myself. I mean, to a certain extent. I'm like we are still now we are slowly getting into the territory where I don't know anything about the subject. And so there's definitely going to be situations where I don't know how to handle something, but being able to being able to practice this stuff while reading the tutorial it definitely helps when we eventually get to the exercise portion of it. Right. So let's delete that and uh oh, wait, we should so we have our x and we have our y. Okay, and then here we can do train underscore x and train underscore y, which is our tuple. Oh, there's also val underscore y. What is that for? Wait, we'll read this in a bit. Equals train test split x, y, and random state 0. Okay, split data into training data and validation data for both features and target. The split is based on a random number generator, supplying a numeric value to the random state argument. Gen guarantees we get the same split every time we run this script. Okay. Oh, wait. I just realized, yeah, okay, I missed something here. That's why it looked kind of weird. So it's train X and train and val X, and then train X and train Y and val Y. So what is, oh, okay, it's because we need training data for X and validation data for X, and then we need training data for Y and validation data for Y. Yeah, okay. I just had to like kind of, say it, kind of like say it for it to make sense to me. Okay, then in our decision tree regressor, apparently we are not specifying a random state anymore. Then we do model.fit, which takes train underscore X and train underscore Y. And then we do predict on val underscore X. At what point are we using val underscore Y? Oh, it's for the prediction. Okay, wait. No, hold on. Oh, val underscore Y is for our, yeah, okay, it's for our prediction. So because that becomes our actual value, right? So it's the actual value compared to the predicted value. Okay. All right. Then we do, so we do val underscore Y and then res. We can comment this. Okay. So let's see if we get this. Mean absolute error is exactly, well, not exactly. No, it's not exactly. It's not exact because I think maybe it's because of the, okay, let's try supplying the same random state that we had before and see if then we get the, no. What if we supply 0 here? So it is off, but yeah, I'm not sure why I'm not getting the same. result. Yeah, each time I do get a different score, probably because there's a different state. All right. Your mean absolute error for the in-sample data was about $500. Out of sample, it is more than $250,000. Yep. This is the difference between a model that is almost exactly right and a model that is unusable for most practical purposes. As a point of reference, the average home value in the validation data is 1 to 1, no, $1.1 million. So the error in the new data is about a quarter of the average home value. That's crazy. Okay, there are many ways to improve this model, such as experimenting to find better features or different model types. All right, cool. So let's move on to model validation. Okay, let this notebook load and then we can do some validation exercises. While this is loading, I think I can read this container documentation, or well, this container, what do you call it? Information, this container conversation that I had with Gemini. And well, the notebook loaded. Okay, great. Awesome. There is a bunch of information here. Wait, this is a new notebook. So I think I should, okay, pi o3.py, and then we can, I mean, this is doing pretty much the same thing as it was before, right? Yeah, this is all that same code. So I don't think we need to do that. Give me a second here. Okay. Yeah, do I need to, should I rewrite this whole thing? I mean, it would be good practice, I guess. But I mean, I have access to the entire thing here already. Yeah, You know what? Okay, we can just edit this code itself because we already have. So that's basically what we would be doing here, right? So just for the sake of making it similar, we can do print first in sample predictions, and then here we can do Iowa model dot predict. No, we have a pred thing here. Also, let's remove the head for the sake of, you know. Actually, where's the predict? Oh, they did uh, head in this case. All right. So then we are good. Right. So then we wait. Why is it? That's weird. Why is it doing that? Bracket was not closed. What do you? What am I missing here? What am I doing? Oh God! I keep mixing up Rust and my God, dude. Okay. Yeah, that was the issue. That was the issue. Fine. So, print f actual target values for those homes, and then we do y dot head. Y doesn't. Y is a series. Will the head function still work for y? Yeah, y is a series. Does the head function still work for it? I mean, let's do it anyways. See, this is one of those situations where sometimes functions or types or something might be they might be generated at runtime, and so the whatever is handling your IntelliSense, it is not able to determine that, hey, this is going to be the function or this is going to be the type or whatever. Um, let's run the thing and see. Wrong script. Okay, yeah, I can get rid of this. Okay, all right, great. So now that that's done, we can move on to, oh yeah, we need to run this. Dude, Meg, how are you doing, man? It's been ages. Meg, how are you doing? Welcome to the stream. It's good to see you. Holy shit, it's been ages. How are you doing? How are things with you? How's Vinny doing? It's good to see you, Meg. Damn, when did that message come in? I think, oh, there you are. Okay. Good. How are you? I'm doing good. I'm doing good. I've been busy. Uh I've been diving deeper into data science and machine learning and AI and stuff. And I've been busy, but the good kind of busy. How about you? What have you been up to? How's life going? Just a couple minutes ago. You're good. Hell yeah. Hell yeah. But how's things with you? How are you guys? How are you guys doing? How's life? I, when's the last time we when's the last time we spoke? Hold on. Oh shit! It was like 2 years ago. That's crazy. Damn. I hope you're doing well. That is awesome. We got married in July. Hell yeah! Congrats on the marriage. I don't remember if I think I might have seen images on Facebook. Like you guys had uploaded pics. I don't remember if I commented on them or if I just dropped a like or well, I don't remember. But yo, dude, congrats to both of you. I'm happy for you. I'm happy for both of you. So what's new? What have you been up to? I'm I don't know. The last time you were here, I don't remember if I'd like completely transitioned to doing just study streams and like working streams, but like these days it's pretty much just study streams and co-working streams. And I'm glad that they actually have a category for that. If you look at the category in which I'm streaming, it's co-working and studying. Thank you. I'm glad that you've been continuing your studies with programming. You must be learning a lot. I have been learning a lot. I've been learning I've been learning a lot and I'm loving it. Funny enough, what I've been learning is actually called machine learning as well. But I'm loving it. It's crazy. There's like so much to explore in this subject, and the website that I'm on right now, this website called Kaggle. This website is for data science enthusiasts and machine learning enthusiasts. And this website is it's like a you can think of it as a hub for data scientists. It provides you with learning materials. It provides you with various types of compute resources. If you don't have, beefy machines to be able to do data science and machine learning stuff on, they actually provide you with compute resources. So like you can set up your code here and run the code on their servers. It's amazing. I bet that's awesome. Do you have an idea what you want to do with it? Yeah. So I have a bunch of research that I want to get into. There's two separate things, right? There's data science and there's machine learning. I'm also additionally interested in something called deep learning, which is machine learning, but with a heavy focus on something called neural networks. So I've been doing a bunch of research on neural networks as well, the various architectures that are available, and I have a very long way to go in terms of that. For data science, I kind of want to explore I want to explore data. There's something called exploratory data analysis where you take a data set and you just study it and learn everything about it and find patterns and stuff in it. That's one thing that I want to do. I also additionally want to take this knowledge into deep learning to be able to develop models for stuff like large language models, stuff like computer vision models, and robotics stuff. There's like so much that you can do with this. I don't know. Once I start talking about this, I get excited. It is it is amazing. Like this is legit a field that makes me so happy to explore. It's crazy. Also, now that I'm actually seeing chat messages, it's good to see that my chat overlay is overlaying well on top of the matrix rain that I set up. That's good though. You're passionate. Hell yeah. Hell yeah. Big time. I'm super excited to like there's course material here We are done with this one, right? Right now it's booming, so it's a great time to get into the field. Hell yeah. AI is exploding right now. It is going crazy. And that's, dude, there's so many different, like a lot of the stuff that I want to do is research related. It's not even about like building final products. It's just researching and exploring and developing this technology a lot more. Stuff like, for example, how large language models work internally, but also how to give large language models more human-like characteristics, stuff like a personality, for example, giving them different types of personality, different types of behaviors, um, and of course, different. If we are talking about like text-to-speech models, then giving them different types of sounds, different ways of speaking, different accents, and um, so much, dude. There's so much for me to explore, and I'm excited for that, dude. Research is the meat and potatoes. Important work. True. Very true. And that's kind of why I spend like so much time digging into a bunch of these things, and I end up getting distracted from what I was initially planning on doing. Believe it or not, this exercise that I'm doing here, I was actually doing this in I was doing this close to a year ago. I started doing this close to a year ago, and then I got distracted while doing research on something regarding this. I got distracted with some of the details, and then I ended up kind of like branching out and going towards deep learning, which I'm also going to be coming back to because fortunately this does also introduce deep learning. Um, but yeah, I did end up getting distracted. But the good thing about that distraction was that the distraction led me towards exploring deep learning more and exploring neural networks more, and quite a lot of stuff like text to speech models, speech to text models, um, various types of analysis models, various types of generative AI models, various types of large language models. A lot of them very heavily use neural networks. A lot of them very heavily use deep learning in general. So I kind of want to go as deep into this as I can because I'm very much interested in the research aspect of it, and I feel like going through a bunch of these courses that Kaggle has provided for us, it's gonna get me there a lot quicker because it introduces you to a bunch of different concepts. Okay, right now we are looking at model validation. We are doing this practically, and we are done executing this cell. Now we have to go into splitting the data. So use the use the train test split function to split up your data. Give it an argument random state one. Give it the argument random state one, so the check functions know what to expect when verifying your code. Okay, all right. Um, I think we have to do it here, right? So train underscore x and val underscore x, and then train underscore y, and then val underscore y equals decision tree, no, test. It was train test split for what? Wait, yeah, what exactly are we train test split? It's one data set that we are splitting, isn't it? So aren't we then passing in? No, I'm having trouble remembering this. Hold on, let me go back here. So we are passing in x and y. Oh, so this is after we have kind of filtered our target variable and our features. Yeah, I need to remember it in that way. Um, we are filtering our target variable and features, and then we set the random state to 1. Uh, right, let's do that here as well. What was it? sklearn dot metrics. I don't remember. Let me go back here. Model selection. Model selection train underscore test underscore split. Okay, and then we uncomment this. And then here we do train test split x, y, random underscore state equals 1. Okay, hopefully we are good. Yes, we are good. All right, now moving on to the next section. Let's read the hints and see what it's if it's teaching us something. So the function you need to import is part of sklearn, true. When calling the function, the arguments are x and y. Ensure you set the random state to so and so. Okay. Then specify and fit the model. Create a decision tree regressor model and fit it to the relevant data. Set random state to 1 when creating the model. Okay, so here we want to do decision tree regressor random underscore state equals 1. Then Iowa model dot fit, and here we want to give it train x and train y, I believe. No, hold on. Yes, train x and train y. That makes sense, right? Because like while fitting the model, when you're fitting the model, you're training the model. So if when you're training the model, then you want to use the training data. Now let's see if this worked. Yes, great, awesome. So we are good so far. BRB, all right, Meg. Oh, I just noticed somebody followed me. Someone named David Vroda. Thank you for the follow. Hello. Welcome to the stream. Probably an hour ago. Um, but yeah, thanks for the follow. I missed the follow by an hour. But yeah, welcome to the stream. Now, moving on here, and yes, I was right about this. You have to pass in the training X and training Y. Then make predictions with validation data. So this would be Iowa model dot predict. We pass in one value, right? We have to pass in the features. So that would be val x, and then what we get back is what we're going to compare with val y. Awesome. Okay, I've got that right as well so far. Okay, run predict on the right validation data object. Run predict on the right validation data object. That was the hint. Okay, great. Thank you for that. Inspect your model's predictions. Inspect your predictions and actual values from validation data. So print the top few validation predictions. Print the top few validation predictions. Okay. So val predictions dot head. Okay. And then print the top few actual prices. How do I get the head for that? I don't think like can I use head for a series object? Is that going to work? Val predictions is not defined. Yeah, it's because I messed up the spelling. Predictions. Okay, what's next? Yeah, it doesn't have something called head. Let's, I guess, compare it anyways. Okay, they have not mentioned how to get the top few values. At least I don't think they have mentioned. Though, wasn't it mentioned somewhere else? So val y becomes an ND array, val prediction becomes an ND array, and then we print that. Okay, either way, we'll compare it this way. What do you notice that is different from what you saw with in-sample predictions, which are printed at the top of the code cell in this page? Do you remember why validation predictions differ from in-sample or training predictions? This is an important idea from the last lesson. Okay, there's a bit of a hole here because they have not mentioned how to. Okay, what's the they haven't given a hint either because they haven't gone into how you can get the few rows of the top few rows of an ND array, but they have taught because like I know that I can probably I don't know how well this is going to work, but I could probably do something like this, right? And that prints out the top few rows, and then I can compare it in this manner. Oh, hold on, dude. We are not that far off. Hell yeah. Yeah, we are actually not that far off. Now, hold on. Um, I feel like I should give some feedback to them regarding this specific thing because I don't think I might have to go through this entire thing again to see if they've mentioned anywhere how to get the few rows, the top few rows of an ND array. But I don't know if I do that, am I being a little too picky? I'm not really being picky though. I'm trying to look out for absolute beginners because absolute beginners would be completely lost here. The only thing they would know how to do because they've never dealt with ND arrays before, right? Though I guess then there would be the aspect of exploration where they could just Google it. So I don't know if this is something I should really be complaining about. Okay, mean absolute error. And in mean absolute error, we want to pass in our true um, y and our predicted y. So our true y is val x. And then our predicted y is val predictions. Okay, let's print this out. Let's go, dude. Hell yeah. We got the thing right. We got the thing right. Okay, so we are officially done with this, and I feel like there's quite a bit for me to explore here. I need to ask Gemini to prepare a sort of exercise for me. This is something good about Gemini CLI, where it can give you it can prepare exercises for you. Like it can legit prepare entire exercises, writing out code files and stuff like that, and then it can tell you, okay, change what needs to be changed here, make so and so changes, and try to find what the bug is over here, try to fix that issue, try to find this, try to do that, and you get to learn in that way. So I kind of want to explore this a little bit with Gemini. Um, Give me a second here. Yeah, I kind of want to explore this a little bit with Gemini. But that being said, give me a second here. Hold on. What is this? When did I get a sub? Who just subscribed, dude? Wait a minute. Is that why I was seeing... Just a second. Just a second. Let me refresh this page. I missed a sub, dude. That's crazy. My bad. Who subscribed? Let me just check. Where's the filter? Because I don't get subs. I don't get subs often. Uh, Give me a second. My activity feed is also not showing me the subs, so I can't see who just subbed. But it's saying... Just a second here. I need I need to find out. Dude, I can't believe I missed that. Okay, I'm not seeing who subbed. Uh, but Meg, it is saying that you are tier 1 subbed for 2 months. I'm assuming it's you. I didn't get... Dude, my bad. My bad. I didn't get any notification. I didn't see any sub thing. Actually, I don't know if the notification popped up on screen and I just missed. Actually, that's a possibility. I might have missed. Holy shit. My bad. My bad. Dude, Meg, thanks for the sub. I appreciate that. Thank you very much. You guys should go check out Meg. Actually, yeah, I forgot to do this as well. You guys should go check out Meg. Meg, I don't know if you still stream, but I'm gonna give you a shout out in case you ever start streaming in the future. Go check out my friend Mick Megs. She's cool people. She's pretty awesome. Um, yeah, go check out her channel. At Again, Meg, I don't know if you've started streaming again. But yeah, yeah, dude, thank you for the sub. I appreciate it. Um, Hold on. I was gonna look for somebody to raid. So I'm going to be in co-working and studying. Okay, okay. Let's see. Who can we raid? I'm trying to look for something that... Okay, procrastinated too close to the sun. Co-working time. Okay, there's somebody here called EgoPath. Let me just go and make sure that their chat is not follower only. Yeah. You know what? We'll go and raid this person. I don't know what they're doing. But we are gonna go check out this person. Actually, I just found somebody else here as well who seems to be looking at plants. What is this person doing? Their name is Pumbaa. I like that. There's a plant and there's a game and they are muted. I think they're on the phone with someone. You know what? Okay, we're gonna go check this person out. They've been live for 10 hours. Um, I don't know if they're planning on ending at some point. What about... wait, what's going on with EgoPath? Uh, okay, right. Hold on. Hold on just a minute. Okay, I hear EgoPath saying something. So we're gonna go raid this person. Okay, so that's gonna be it for today's stream. Hopefully we're gonna stream again tomorrow. I'm definitely gonna try and get through the next chapter, which is underfitting and overfitting. But before that, I want to practice a bunch of this stuff, and I'm gonna see if Gemini can prepare some exercises for me that I can practice. Um, and then I'll move on to the next chapter. I'm excited. I'm excited to see what more we can learn. And soon we're going to be done with the entire Intro to Machine Learning course. So I'm pretty excited for that as well. That being said, that's going to be it for today. Meg, thanks a lot for stopping by. Thanks for hanging out. And thank you so much for the sub. Dude, I appreciate that. And my bad, I didn't notice that the sub happened because there was like no notification. There was no, um, nothing showed up in my dashboard. The even now in the activity feed, it's not showing anything. I guess it was a Prime sub maybe, and maybe they don't show notifications for that. I don't know how that whole thing works because like I don't get subs often, so I don't know too much about that. But yeah, thank you for the sub. I'm gonna stop talking now before the raid timer runs out. I hope you guys have a nice day, and I'll see you all next time. Peace.